A researcher has a clinical dataset that could advance cardiac care. It sits unused because two questions have no easy answer. First, is this use actually consented? And is it de identified enough to share? The easy answer is no. Therefore, the data stays in the drawer and the next study never runs. Today, there are two separate worlds. Consent tools know what was permitted but do no de identification math. De identification engines compute risk but are blind to what the consent actually allows. Nobody joins them. Lupta is that join. It reads what was consented, computes what the data reveals, and ties every decision to the clause it restrains.
Now, to understand the problem better, let's take a hypothetical example of Dr. Meera. Dr. Meera ran a 3-year heart study, and a colleague comes in and wants the access to the same dataset. They are stating that they will be building a model which will be flagging at risk patients early. So the cause is for good. But for Dr. Meera, there is no easy way to answer the question whether she can share that dataset or not, because removing names is not enough. Privacy researchers use k-anonymity to come up with the de-identification risk. So, in plain term, it means how many people look exactly like you in that dataset. So, if k is equal to 1, which means that every row in that dataset is uniquely identifiable. At the same time, we have generalization approaches which can be used to suppress the rows which have k is equal to 1. So generalization approaches mean converting the ages into bands, converting or masking the pin codes and other identifiers so that we can mask up some information, suppress the rows which have uniquely identifiable information, and then try to share whatever is salvaged after the generalization approach. Now, coming back to the original problem that we begin with, whether to share that dataset or not. To answer it, let's first retrace what all do we even need to come up with that answer. In its essence, we need three things to answer this question. First and foremost is the consent form itself, which was used when we were collecting that dataset. Second becomes the dataset itself, which is already with Dr. Meera. And third becomes that new request or the proposed used, which is coming from that colleague. So we have all those three things with us.
The way I built Lupta, these three things become the inputs. Lupta reads the actual consent document, checks the proposed use, computes re-identification risk, and returns an auditable decision. Every claim is cited and every number is proven. Now let's watch a real Lupta run in the CLI. Quick walkthrough on the data. First, I'm working on a synthetic dataset, which you can also generate using the script provided in the repository. The dataset is the heart study, which I mentioned as a test case for Dr. Meera. And then I have three versions of consent documents. So these are in different scope and allow different downstream use cases for these datasets. I also have some lookups already created so that when we try to generalize, we have some real data to work with. All of the agent runtime is over here in the agent folder, my prompts, my tools, and the runtime itself. And then I have my engine, which is the deterministic de-identification, utilizing k-anonymity as of now. And these are exposed as tools to the agent when it's working. So that's how it's set up. And then we have the tests over here. We also have support for adding third-party terminology services. Terminology services can help us to find the rare disease conditions so that when it is generalizing, the agent is more aware on computing the re-identification risks. Okay, so let's watch a real Lupta run in the CLI. To get started, I'll set my Anthropic API key. Then I'll turn on the verbose mode so that we can see the agent reasoning. Now I can simply use my Python to run it. I need to specify the consent. I'm going to use the variant C. The variant C is the one which is silent on the reuse and output me this file. So now we are connected to Anthropic SDK and talking to Messages API. The first and foremost tool the agent has called is profiling the dataset. so that it can understand what are the identifiers. It find out there are two direct IDs. These are the quasi-identifier columns, and it also find out the sensitivity attributes. Yeah. Now the proposed release is age, sex, pin code, admission rate, diagnosis. Okay. So it's gonna run a risk on that QI set. So these tools, these are deterministic tools. So Claude can never hallucinate on this. These tools will always generate a real number. It tells us the raw data set is fully unique. K is equal to 1. Prosecutor and marketer risk are also 1, which means every one of the 800 records is a singleton on age, sex, pin code, and admission rate. Now it's going to try a generalization strategy. It's going to convert age into bands, pin code into prefixes, admission dates truncate. Again, these are the tools that are coming up from the engine, so that again all of these are going to return real numbers. After generalization, it's going to compute the k-score and also the suppression impact, how many rows would be exhausted if we try to use this generalization. So right now, it's saying even with the age bands and the pin code generalization, the info loss is already 0.95%, which means 95% of the rows have to be deleted if you want to salvage this dataset based upon the generalization it applied in the first step. So it's going to apply another round of generalization, and itself is saying it's going to test the most aggressive reasonable coercioning, because the use case is for genuine case. After the generalization and the loop it completed, it said the final verdict is deny, because I'm working with India's DPDP laws. So the ambiguity in personal data sharing, if it's not specified, that does not mean that data is ready to be shared. That's why, to honor that, the final verdict is deny. And the generated artifact is this. Let's quickly preview this. So this is the file that it generates for us, and it has all the information why we cannot share this dataset, and also grounds and cites on what provisions under the DPDP Act. Let's try a different ask, the proposed use for this dataset. I'm going to use the same consent. I'm going to out new memo.html, and then for the use I'm going to say aggregate stat only, no patient level rows. So the verdict is you can share this dataset, but you have to apply transformations to it. Let's see the generated artifact. It's this one. So it's saying approve with transform, and it's also going to tell us what transforms we need to apply before sharing this dataset. So both ways. This is the heart of it. Claude does the judgment a statute demands, reading messy consent languages, spotting hidden identifiers, reasoning about who could be re-identified. But Claude never does the arithmetic. Every K, every risk score comes from a deterministic tool. Judgment from the model, math from the math. And the citations aren't guessed. They are verified against the DPDP Gazette, down to the exact section and the traps most people get wrong. India's data law is enforceable May 2027. Lupta is the tooling that gets ahead of it, built by someone who can read both the biology and the law.